It's time to start learning about some severe weather. Today's lecture is all about thunderstorms, and it comes from pages 314 to 323 in your textbook. Your textbook is going to come up with a fairly complex way of describing different kinds of thunderstorms, different categories of thunderstorms, and so on. So I'm going to help you sort it out. The book is going to start off by talking about air mass thunderstorms, which are just what you probably have heard of described as thunder showers. And these have a very specific life cycle that the book describes in detail. The first stage is called the cumulus stage, then there's the mature stage. I really like the figure at the top of page 315, by the way. And later they go through their dissipating stage. And so they have a very short little life with just 3 little steps through them, no big deal. Then the textbook talks about severe thunderstorms, and it starts dividing them up into different kinds of severe thunderstorms. There's mesoscale convective systems, which they call MCSs, supercell thunderstorms, squall line thunderstorms. It's all a bit complex and not all that clear in the book. Let me draw you a little diagram here to help you understand what they're doing. If you take the set of all the thunderstorms that are out there, the book says you can divide them into 2 types: air mass thunderstorms and severe thunderstorms. Now, I'm not trying to say, by the way, that there's like half of them are air mass and half are severe. In fact, very few are severe. But I'm just trying to diagram as to what the book is trying to do. Now, the book says there's several different types of several different types of severe thunderstorms. There are the supercell thunderstorms, and there are the mesoscale convective systems. When you read the book, and you keep that division in mind, that they're both severe thunderstorms, but supercells are isolated, whereas mesoscale convective systems are groups of storms, it'll be a little more clear as to what's going on. In fact, the book further divides mesoscale convective systems into 2 subtypes: squall lines and mesoscale convective complexes, or MCCs. So it's a little bit of a complex hierarchy the way the book divides it up. It's a little strange. Most textbooks do it differently, but actually it's fairly useful. Let's just look at a couple examples of each. These are just basic air mass thunderstorms off the coast of Florida, seen on radar on the left and on satellite on the right. They're just little pop-up thunderstorms, little thunder showers. There's no severe weather associated with any of this. Supercell thunderstorms are huge, isolated thunderstorms. They are monsters. They last for hours. They have these huge anvils. They are often associated with tornadoes. Here's some supercell thunderstorms, some other views of them. Notice the one in radar in the lower left corner. It's big. It's probably the size of a county. It's isolated. It's a big thunderstorm. Mesoscale convective complexes, or MCCs, are groups of thunderstorms occurring together. And what specifically makes an MCC is that it's a very round area of thunderstorms. Notice how in both of these enhanced satellite pictures, the coldest clouds, which are highlighted in blue on the left or in black on the right, are a fairly round region of thunderstorms. And you'll learn all kinds of interesting things about MCCs in the textbook. There's also squall lines, which I think most people can kind of picture what we're talking about. It's a band of thunderstorms moving through. That's another type of mesoscale convective system. Here's just a nice picture from the space shuttle of a squall line. Here's just another picture. You get the idea, though. Okay, so if we move on, and then, okay, you can see that we have mesoscale convective complexes in the textbook on page 317, and the term I have highlighted here is their outflow. Make sure you understand what outflow is. Don't worry about this box on page 318. Page 319, you move on to squall line thunderstorms, and you learn about what makes them form in those lines and where they happen with respect to cold fronts and warm fronts and so on. And there's just a little more about squall line thunderstorms. And there's some terms here. I highlighted gust front because that's important, but there's some vocabulary words here that are kind of very detailed cloud structures that like a storm chaser would be interested in. That's not really the point of our class, so don't worry about things like shelf cloud and I forget what the other one I crossed out is, but that's beyond the scope of what we do in this course. And then finally, supercell thunderstorms. That's a very complex diagram of how a supercell thunderstorm works on page 223. I'll get back to you as to whether that's a good diagram or not. I have my doubts about that picture. And some more details about supercell thunderstorms. Notice, by the way, down here in the corner on page 323, it points you to an activity on your textbook CD about Doppler radar. You must complete that activity. Okay, we're not going to have time, we can discuss it individually or at the review session or something like that, but we won't have time in class to discuss how Doppler radar works and what it all sees in contrast to conventional radar. Rather, there will be questions on the test about it, but you'll have to have done the activity on the CD in order to understand that material. Okay, I hope that straightens everything out. If you have any further questions, please get a hold of me. This has been Dr. John Truggy, copyright 2006.